So where the variables are the key factors in graphing a function. The only variable here, the domain variable, is in the bottom of a fraction. So this is going to look something like this, a reciprocal function. The basic reciprocal function is 1 over x, so this graph looks like this. Ours is just going to be shifted and stretched and things like that. So probably best way to graph this without a graphing calculator. I guess you wouldn't be here if you had one available on your test. Best way to graph this is with probably an x and y table. What we're going to do is we're going to plug in numbers for x, see what they spit out for y, and those are going to be dots that are going to be on our graph. So if I plug in a 0 right here and for x, I get 9 over 3, which makes 3. And then 3 plus 6 makes 9. If I plug in 6 into my function, 6 plus 3 makes 9. 9 divided by 9 is 1, and then that 1 plus that 6 makes a 7. So if I plug in something like negative 6, negative 6 plus 3 makes negative 3. 9 divided by negative 3 makes negative 3, and negative 3 plus 6 makes positive 3. So you can continue like that and fill up the table, which I'll do for you real quick. So let's see if that's enough dots here, because this is telling me, as 0, 9 tells me to go 0 on the x, 9 on the y, and put a dot. We'll just label that as 9. And then 6, 7, it tells me to go 6 on the x, 7 on the y, and put a dot. Negative 6, 3 tells me to go 6 spaces back on the x, and then only 3 on the y. Negative 12, we'll put that way over here. 5 tells me to put a dot over there. And then we got negative 4, negative 3, it's a dot down there. So might be tough to see, especially if you don't know what the function is, if you have no clue what the function looks like. But we already said we do. It's supposed to look something like this reciprocal function. So you can see the reciprocal piece happening here. It's going down, this one's going up over here. And the reason why it's making that peak is, well, one, is because it's supposed to have something similar to the reciprocal function. But the big reason is that x equals negative 3 can't happen. It's a vertical asymptote, because if you were to plug in negative 3 into this function, you get a divide by 0 problem. So here we are, right around x equals negative 3, and we're never reaching that. The dots start like shying away from it because we can't get exactly negative 3 out. And then there's also a reason for why we have a horizontal asymptote over here. In case you studied that in class, horizontal asymptote just happens when the power in the power on the top is smaller than the power on the bottom. So that means that the horizontal asymptote is usually at y equals 0, but it's been added 6 units up. The whole function's been shifted 6 units up. So that's why at y equals 6 we're never touching. The other big piece of this is the domain and the range. The domain, the domain is all x values that you can get out of the function. Okay, so look at your function and think about what would break the rules, and you just want to make sure you avoid those numbers. And the big things you look for in domain range are two. You look to see if you have a divide by 0 problem, and you look to see if you have a square root of a negative. And if you plug in x equals negative 3, you do have a divide by 0 problem. So we need to exclude negative 3. Teachers usually like that in interval notation. So interval notation starts with the smallest value you can have, in this case negative infinity, because you can think of the smallest negative number you want. But then stop that interval when you get to negative 3. The train jumps over the rails here and picks up after negative 3 and goes to positive infinity. Because this parentheses notation means you can't have exactly negative 3. Can't have exactly negative 3. You got to jump over it. So that's our domain. There's only one problem, and we jumped over it with our interval. And now the range is usually best found by looking at the graph. And we've got a rough sketch of the graph that's going to be enough to tell what the range is. The range represents all the y values. So the lowest y value we can have is, as far as you can imagine, negative infinity. But there's a problem in the middle. We said we can't get exactly 6. Can't get 6 out. And again, that's because in this function over here, there's no way to make this equal 0 so that you have 0 plus 6 equals 6. You can't get 6 out of the function. So your range has to skip over the number 6 because of that asymptote there. So we're going to skip over 6 again with that union symbol, and we'll say 6 to positive infinity. That's our range.